So you want to make a multiplayer first-person shooter, and you're wondering, where do I start? Or maybe you are just interested in how they work behind the scenes. Well, you have come to the right place. In this video, I will teach you the basics on how to make a multiplayer competitive game. If you are looking to make an FPS game, before even starting, you should know that making one is probably the hardest thing you are going to do in your entire life. So see this as a formal warning. On the difficulty scale, it would probably rate as very difficult. Also, be warned that the amount of work is substantial. Most of your time will not be spent on making character models or fun skins. It will be on making the backend of your server and your client as fast and minimal as possible. If you have a partner or partners, now is the time to beg them for help. One more thing to mention. If you are serious about making a multiplayer game, you should know that you need to build it with multiplayer in mind from day one. You cannot convert a single player game into a multiplayer game. You would essentially be making two games. One more disclaimer. I will not be showing any code or implementations in this video. It will only contain the general structure of how a game server works. If you are looking for a tutorial on how to do certain aspects of the topics discussed, leave me a comment and I will try to help. Now that the intro and warnings are out of the way, let's dive in. A multiplayer first-person shooter has a few design requirements. Because it is real-time, it has to be fast. There is no point in playing a competitive game if you keep lagging around or your frames per second is under 30. So optimization is key on all levels of your game, server and client side. Second is the amount of data you send to each player. Again, since it is real-time, the packets you send have to be as small as possible to arrive at a consistent pace. Which brings us to the third requirement, consistency and reliability. When you shoot at an enemy, there can be close to no room for interpretation. If the player's crosshair is on the enemy, it has to hit. If it doesn't, you can't call your game competitive. And last but definitely not least is that you can, under no circumstances, trust your players. There will always be some that will try to cheat, and it is your responsibility to not let that happen. Everything you do must be authenticated by the server. With the design requirements out of the way, what does a server actually do? Well, every server follows these three basic steps during game time. First, it collects all the inputs that the players did. Most of the time, this is done through bit flagging to keep the message size as low as possible. After it has done that, it executes those input commands and computes the game state. Again, while doing the necessary checks to make sure everything is valid. Then, when it has done that, it sends out the current state of the game to all clients. This ensures that all the clients are seeing the same version of the game at all times. It does all of this during what we call a game tick. This is a function that the server and client will continuously run over and over again. 90% of the time, this is done between 20 to 60 times a second. The lower your tick rate is, the more you can process at one time, but the slower your clients get updated. Vice versa with a higher tick rate. So it is always beneficial to have a higher tick rate when possible. Also, one other thing is that the time is synced between client and server, so they are always on the same tick. In most cases, this is done by sending a timing package from client to server and back. Then it uses the ping and the server time to calculate the current time. Just a heads up, from now on I will be using message, packets, and package interchangeably, as they all mean roughly the same thing. Now that we know what a tick is, how does it actually function in detail? Like we just discussed, the server collects all inputs from the players. This is done by having an incoming message queue. It is basically a big stack of all incoming messages. It collects all of these messages asynchronously. This is needed because of the delay between the client sending the message and the server receiving it. The queue can contain much more than just input. It can also contain requests from the client or identifications, which the server might use to verify the user. After it collects all the incoming messages, it then makes an outgoing message queue. In reality, it won't make this every tick, but I wanted to include it because we will need it later. Then the server will process each command. This includes moving the players according to their inputs, but may also include physics or anti-cheats if you have it in your game. If you have any other messages that come in that the server needs to send a reply, you will also do this by adding the reply to the outgoing message queue. After which comes maybe the most important step of the process. The server will take a snapshot from the current state of the world. This includes, but is not limited to, the position of every player, changes of health, firing of guns, throwing of grenades. Depending on your specific game, you might need more or less data to be sent. There is really no cookie cutter method for taking these snapshots as they are different depending on your requirements. The last step is to send all the messages to the players. Most of the time this is done through combining all of the messages for a single player into one and then sending it. Again, there are different ways to do this, but most AAA games use a priority system where the most important messages are sent first. Now for a big warning before you start coding. Beware of your limitations. I mostly mean bandwidth and internet speed. The golden rule is that you assume that your client has an average internet speed of about 2 to 3 megabits per second. The same should go for your server, although if you are hosting it on the cloud, it will probably lie a bit higher. This might seem sufficient, but know that this is divided by the amount of ticks per second and the amount of players. Also, keep in mind that the amount of data sent exponentially scales with the amount of players. Another thing to keep in mind is the amount of time your tick takes to process. If your tick takes longer to process than your tick speed, the server will fall behind and desynchronization will occur. This is one reason to really play with your tick speed. This brings us to the next topic, UDP versus TCP. If you have no idea what I'm talking about, take this as a hint that you might need to learn a bit more about internet protocols. But I will give you a very brief and quick rundown. TCP is a protocol that ensures that your package you send arrives at its destination and is in the correct order. It is designed to be reliable but not fast. UDP, on the other hand, is designed to be as fast as possible, but you don't know whether your packets will arrive or in what order. You might think that using TCP is the best option, but you will never find a game that uses TCP for everything. All games that I know of use UDP for as good as everything. This is basically because you can write your own reliability layer on top of UDP to make sure that your packages arrives. There can be instances where you might want to use TCP, but as a general rule of thumb, use UDP. Another thing to keep in mind is that the maximum size of a UDP packet is 508 bytes. This is not a lot, so make sure you do not go over these limits or you might lose data. If you implement everything I told you in this video, chances are you will see a choppy, unresponsive game. For the server side, this is fine. Most servers are actually like this, but your players won't appreciate this. They want their experience to be as smooth as possible. And if you thought the things I talked about were difficult, getting your game smooth is on a whole other level. You will find people in the industry that obsess over how to do this. There are many talks and articles online on how to do this, but there are a few standard ways most games achieve this. The first way is to have players smooth between the previous tick position and the current one. We call this interpolation. This is done by letting the other players essentially exist one tick behind in real time. This means that what you see on screen is actually not real time, but close to it. This is why we say that there are no real time games, since everything you see around you is actually one tick behind. The next thing a lot of games use is extrapolation. In the case that a snapshot might be a bit late or doesn't arrive at all, you don't want everything around you to just stop moving. This would give you a very choppy and unrealistic effect. So programmers came up with extrapolation. This basically means that all the other players will keep moving in the direction they were previously moving in. But beware, because this could cause some desynchronization issues if it persists for multiple ticks, since the other players might have started walking in a different direction. The last thing I want to talk about today is player prediction. This is a technique where basically you run the movement code on the client itself which ensures that the player will always move smoothly for his own perspective. This avoids the time between sending the inputs and receiving the snapshots. Then, when the snapshots does finally arrive, the client just checks whether or not it is close to the correct position. Thank you for watching. If you have any questions or suggestions, leave a comment and I will try to answer them. I will also try to make more videos like this to explain the process better.